Okay, so yesterday was pretty simple, right? We start with a 5-number summary, and then we talk about the range. Just as a little reminder, range was how we saw the dispersion in the data, right? How far apart was the data. Now we're gonna move into something that we called variance. Now variance, what the variance does is it's a measurement. It's a number that we're gonna get, but now this one, it measures the degree dispersion of the data around the sample's mean. Right? Sample means is basically the average. We're going to be looking at dispersion around the average. Now, I'm going to introduce you guys to a Greek letter, okay? Now, this little one right here, it looks like a little O with a little line on the top. Let me write it over here. We write it like this. Now, this is a Greek letter that's called sigma. In this case, sigma squared. Sigma squared, this is the symbol we're going to use for variance. There are two types of variances. So notice I have two different formulas. Now, there's a sigma sum. There's another Greek letter. You guys see this thing that looks like an E? The sigma sum. This basically means we're going to keep on adding basically a few numbers. So there's going to be some addition, but so that we're going to add some numbers. So notice on both of my formulas, I add some numbers. It's very, very similar here. I'm going to talk about this little U shape in a minute. So I just want to emphasize, I'm going to be adding some formulas. I want to be adding some numbers, but then I divide them by a different number. Now here I have n minus 1, and I have here n. There's a difference of my formulas. Now, the formula we're going to be using, this one on the left, this is if we have a sample. We just have a sample. Now, n is how many numbers were in our data. So n minus 1 is obviously one number less. Now, I'm going to be dividing by one number less if I'm using the sample. So sometimes you want to know what's the variance of a sample. Now, this other formula, this is if I have the population. I have the whole population, so I know how many numbers are in my whole data. Now the samples, what if I don't have my whole population? Those are the two formulas that we use. But to be honest, the one I'm going to be using the most will be the one for population. Even though I just might give you some data, and we might see it as that's just the sample, I'm gonna be calling it the population. Okay, so this is the formula we use the most. Some on your note, on your instructions, I will emphasize this is the population. Assume this is the population because I want you guys to use this formula. This is the formula we're going to use. Not that divided by n minus 1, divided by how many numbers there are. Now that sounds like a mean, like an average. Now, this little U shape, I mentioned I was going to talk about this little U shape, right? You guys see it in both cases. This is what we call the mu, okay? Now, the mu is basically the average. So here I'm looking at the distance between each number from the average, and then I square it. Okay, so let me show you guys with an example. Let me show you guys with an example. So it's going to be a little bit easier to work with. Now I have a list of numbers, and I have it twice, right? You guys see the list of numbers here on the top. I have this list of numbers, but then I also have the same list down here. So this is the list that I'm going to be using, okay? So when I say the numbers from the list, those are the numbers that I'm using. The numbers that are on my list, you guys see them on your notes, are the numbers 2. So I'm gonna write them here: 2, 3, 3, 7, 20, 22, 33, 35, 35, and 36. Okay, we know how to do the average of a list of numbers. All right, we just add them all. We add them all and then divide it by how many numbers there are. So I'm gonna grab my calculator. I'm gonna add all my numbers, divided in this case by by 10, because there's 10 numbers. Okay, so it gives me 196. 196 divided by 10. My average, or my mu, because I'm going to start using the Greek letters, my mu, oops, let me erase this line right here. My mu is going to be 19.6. I know I'm looking for variance. I asked you guys we're going to be working on the variance, but I'm finding right now my average, or my mu, 19.6. I'm going to be using my mu a lot. I'm going to be using my average right now. Okay, now that I found the average, let me find out how far apart are each of my numbers from the average. So for my first one, I'm going to go 2 minus 19.6. So this number, how far apart is this from my average? It is okay if it's a negative number. 2 minus 19.6, I end up finding negative 17.6. So I always go this number minus the average. Okay, how about the next number? 3 minus 19.6. I happen to get negative 16.6. So some numbers are going to be negative because they're less than the average. Some of my answers here are going to be positive because the number is more than my average. So I end up finding the distance between each number and my average happens to be negative 16.6, negative 12.6, positive 0.4, positive 2.4, positive 13.4, positive 15.4, again, positive 15.4, and then lastly, positive 16.4. So remember, all I did was I subtracted each number minus the average. So when I look at the dispersion of my data around the sample mean, okay? Good, so that's not that bad. So as a matter of fact, I even give you guys the directions here. X is basically each number from my list. X minus mu, basically each number minus the average. So not that bad. Now here, on my next list, X minus mu all squared. Cool, so it's not that bad. Negative 17.6 all squared. The good thing is that because I'm squaring everything, so everything squared is going to make everything positive. I'm not going to have negative numbers again. So negative 17.6 times negative 17.6. Remember, I have negative 17.6 all squared gives me 309.76. My next number, negative 16.6 all squared. So negative 16.6 times a negative 16.6 becomes positive 275.56. And then my other list, the rest of my list will be 275.56, 158.76, 0.16, 5.76, 179.56, and I have 237.16. Again, 237.16. And lastly, 268.96. So all I did was x minus mu all square. Let me come back to my formula that I introduced you guys to earlier. I'm not quite done yet. I haven't found my variance yet. I'm still working, okay? So we're figuring out what the variance is. And remember, I'm using this sigma squared. I'm using the Greek notation. And then I had xi minus mu all squared. And then I also mentioned this little e looking thing looks like the sum. So I found out each x minus the mu all squared. It seems like I'm just going to add them. I'm just going to add them all and then divide it by n. So how many numbers there are. Okay, pretty simple. So what I'm going to do here, I'm just going to add them all. Remember I said E, that the sigma, that one thing that looks like an E, the sigma meant repeated addition. Okay, so I'm going to add them all and then divide it by how many I have. Again, I'm using the population mean. I'm not using the sample variance. I'm using the population variance. So I'm dividing by n, how many numbers I have. All right, so I add them all, divided by 10, because there's 10 numbers. Now my variance, notice how here I have a little symbol here at the bottom. My variance will be 194.84. Okay, so let me come back to how I figure out the variance. I have a list of numbers and I listed my numbers. So let me switch to blue to go over my steps. I listed all my numbers. From my list of numbers, I figure out a mean. What was the mean of it? Okay, then I figure out each number minus the mean. So I came out with a different list of numbers. Each number minus the mean. I squared each of my numbers on the second list. I squared each of them. And then I happen to just add them all, divided by how many there were. So I basically got the average of the third list. And that is what we called variance. Okay, so not too bad. I know for the homework, I'm going to be asking for variance and standard deviation. Okay, so far we know how to get the variance. Variance, a little bit of work. I'm not going to deny that. A little bit of work, but not impossible. Okay, variance will be pretty simple. Then I'm going to use the standard deviation. One thing I want us to emphasize, the variance, the symbol for variance, remember I'm using the Greek letters. The symbol for variance, it looks like that, sigma squared. That's variance. Now for standard deviation, notice I listed standard deviation and then boom, I have that. Okay, so I'm gonna say, well, what's standard deviation? Well, it's a numerical measure. It's a number of the overall amount of variation in a data set, so it looks like about the variance, and can be used to determine whether a particular data value is close to or far from the mean. It is the square root of the variance. Okay, wait a minute. What did you just say, Mr. Leonzo? It is the square root of the variance. Okay, so now I'm looking at the symbols. Variance was sigma squared. As a matter of fact, let me write VAR for variance. The variance is sigma squared. The standard deviation, let me abbreviate that as standard. So ST for standard, and standard deviation is just sigma. Okay, so once you have your variance, in order for you to find your standard deviation, just get the square root of it. Okay, so for my standard deviation in this case, I'm going to be looking at the square root of 194.84. I know my variance. For the standard deviation, let me get the square root of that. Okay, so I type this on my calculator. I'm going to round my answer to 2 decimal places. Okay, so let me see. This case, it is 13.96. I rounded to 2 decimal places. We usually go for 2 decimal places. Sometimes I might remind you, round it to the nearest hundredth. You're like, 100? That sounds like 100, a number with 2 zeros. Yes, that means round it to 2 decimal places. If I wanted 1 decimal place, I would have said tenths. So now we know how to get the variance and the standard deviation. And I'll be honest, my example is harder than your homework. My example is long. I have 10 numbers. Your homework, I might just give you like 5 numbers or 3 numbers or 7 numbers, but not this long. Okay? So again, get the variance. Just give me a number. Sometimes I might ask you for the variance, but if I ask you for the standard deviation is the square root of the variance.